Now we're going to go over the homework from pages 32 to 33, right? First assignment. Problem number 51. Oh, I didn't realize I had put too many of these fractional ones in there. We're definitely getting into these today, so. So if we are actually performing the indicated operations, which means just distributing, right? Multiplying. What is the process if I multiply a to the m times a to the n? What do I do? Add those exponents, right? So y to the 1/3 plus 2/3 would be 3/3, which is just 1, y to the first, plus y to the 1/3 plus 5/3 would be 6/3 is squared, right? There it is. Not as hard as we thought it was. All right, square root of a plus, minus regular b times square root of a plus b. Don't make fun of my cursive b's. All right, FOIL it out, right? What is the square root of a times the square root of a? Plain old a, right? The outer would be plus square root of a times b, right? The inner minus square root of a times b. So they're canceling, right? Minus b times b, b squared. A minus b squared. Feel good about that? Just a little bit weird. All right. 57. Have we gotten all the ones? Anybody want to call out one that from earlier? Are we good on that? All right, 57. Oh, yeah. This is actually setting you up for what we're doing today. If I could replace this x minus 1 with like a big old z and replace x squared with, say, a. So let this be z, let x squared be a. I would then have z minus a. Could you FOIL that out real easily? Just what? Z squared minus a squared? It's like the difference of the factored form of the difference of two squares. It's the same thing here. This would be x minus 1 quantity squared minus a times a, or x squared times x squared would be x to the 4th, right? I would be perfectly happy with this as an answer. It'd be easy. I mean, obviously you could FOIL that out. X squared minus 2x plus 1 minus x to the 4th. But it doesn't really get you anywhere. Is this visible on the screen for you? Good enough, close enough. But this one is just the beautiful answer because if you can just recognize that as like, you know, a blob plus a different one, and the same blob minus that means when you FOIL it, the outer and the inner always cancel out, don't they? Right, 69 is factoring 14x. All right, this is I feel your pain on this one. If you're stuck without a calculator, right? We're going to multiply the 8 by the 15, right? Or times negative 15, right? You know what? I don't even think I want to multiply them out. Because I know all the factors are there, 8 and 15. How does 8 split up? 2 times 4. How does 15 split up? 5 times 3. So let's try, we're trying to, or subtract to be 14, right? So that's 12 times 10 won't do it. What's 12 times 2? 24 and 5. That won't do it. How about 20 and... You see what I'm doing? Okay. Because I don't really care what the big number is. What I care about are two numbers that multiply to get that big number, right? And so I'm just splitting up the two factors that I know, 8 times 15, right? And then I'm just regrouping and trying to test different combinations of 2 times 4 times 3, or really 2 times 2 times 2 times 3 times 5, right? All of those are the prime factors of whatever that. All right, 4 times 15 would be 60 times 2, 120, right? Okay. But so if I just combine the 4 times the 5, I get 20 times 2 times 3, 6. 20 times 6 is that 120. And then negative 20 and positive 6 is negative 14, right? So that's the toughest part of factoring with the leading coefficient. Then what do we do? Keep that 8x squared plus 6x minus 20x minus 15. Doesn't matter if you do minus 20x plus 6x. Not really. You're still going to just factor by grouping. 2x comes out. Is that 4x plus 3? And a negative 5. Positive 4x plus 3. And then it's just magical because those match, right? Those are that's a common blob. Pull out that 4x plus 3. And what's left? 2x minus 5 is left. That's by far the toughest one to me so far. $71. I want you to bear with me on 71 because I believe this is one that you shouldn't have to take it to the master product, I don't think. The reason I think this one has turned out to be easier than the one before is because this is a prime number. What are the only two things that multiply to give me 3? And this is also a prime number. What are the only two numbers that multiply to give me 5? 1 and 5. This is a perfect one for you to go, I'm going to try trial and error. Because 3x squared, we got 3x and x, or x over here and 3x over there, right? And this is a minus, and we're multiplying to be positive and add to getting negative. So they're both going to be negative. Agreed? And then we just need to fit in the factors of 5, which are only what? 1 and 5. Is it 1 here and 5 there? Or 5 there and 1 there? Well, if I did 5 and 1, I'll get negative 3 minus 5 is not 16. So let's, 1 there, 5 there would be negative 15, negative 1, found it. What do you think about trial and error? Yeah, because this is just a prime number, you only have 2 things to multiply. It's worth our while to just put them down 3 times 1, right? And because this one is prime, the only 2 things that multiply to give me 5 are 5 and 1, or in this case, negative 5 and negative 1, right? So it's just a matter of, is the negative 5 going here or going there? And we always do the FOIL thing to check it. 3 times negative 5 is negative 15x. And negative 1 times x is negative 1x. Negative 15 minus 1 gives us the negative 16. This is the testing stage, right? $73, oh yeah. Plus 2 plus 12. Now, I have every confidence that if you had seen z squared plus 8z plus 12, would you have been able to factor that one? Z and z. What do we ask ourselves? What 2 numbers? Multiply to get 12, add to get us 8, 6 and 2, plus 6, plus 2, done, right? This problem is no different. It's just that this is a blob squared. If you want to use substitution, you can. And then at the very end, change that z back to what? 3x plus 2? And then one more step will make it look completely together, right? How many of you tried to FOIL that out, distribute, combine like terms, and then factor? Would you get like 9x squared plus 30, so 24, yeah, plus 36x plus 32. Yeah, that was an ugly one to factor, wasn't it? But I bet it factors into this. Yeah, so much easier to recognize what I call blobbage. If you can find a blob and just kind of substitute it or whatever, then you can realize, oh, that's not a bad function to factor, is it? Or expression. So today, we are going to continue that, okay? I'll go ahead and stop this recording, so I'll call it